Welcome to our next presentation. This presentation is done by Zacharias Kull and Patrick Grütter, both working at Elka. They're talking about how you efficiently and easily get your data ready for AI with the Smart Data Lake Builder. And we're even going to have a demo today. So enjoy the presentation from Elka.
Thank you. Thank you for the introduction. We have the pleasure to show you Smart Data Lake Builder today. First, motivation and concepts, and then a demo at Databricks Azure. An inquiry of 2016 showed that data science is mostly data preparation and engineering. And I think it hasn't changed much since then. How much are you spending on models and algorithms, and how much on data preparation? I can't get into the details now, but often the problem is we have big data, but we have not smart data. Smart data, it's big data, but it's value added. It's transformed into business terms and business entities. It's verified, data quality is monitored, and security and privacy concerns are handled. And hopefully there is a data catalog so you can find it. We should share more smart data in our organizations and beyond to become more efficient in analytics. Let me show you an example we did with Swiss Federal Railways. The train run history archive are 3 huge XML files every day. It has complex schema, and you don't want to open that and understand it on your local computer. In a first step, we extract 10 technical entities, not fully normalized, but queryable by SQL. In a second step, then, we transform this into 3 business entities, so-called smart data, which are already used by more than 10 use cases. A smart data lake adds additional layer on top of a normal data lake. This architecture provides a strong data foundation for efficient AI and ML. But there is a drawback. Multiple layers are complex to operate and maintain. I show you an example of the lineage of an analytical app we built. The black bars are data objects, in this case Hive tables, and the paths you see are the transformation, the flow of the transformation. How do you manage such complex data pipelines? Well, data warehouses do this already for some time. They use metadata and automation for this. What we would need is an automation tool for big data, based on big data technologies, combining the best of both worlds. And that's what we built together with Swiss Federal Railways. It's called Smart Data Lake Builder. It's open source. It's mostly based on Apache Spark under the hood. And it runs in the cloud, on-premise, or on your local computer. Let me explain you the core concept behind it. Smart Data Lake Builder is metadata driven. That means you have to define data objects, the location and format of your data, and the actions, the transformations you want to apply and their dependencies. And then Smart Data Lake Builder creates the pipeline on the fly and executes it. A simple example to copy a CSV file in a database looks like that. The advantage of such an approach is you have no code for easy tasks. It's DevOps ready. If you want to ingest several hundred tables from a source system, you can generate this configuration, and you get a lineage and a data catalog. Now we want to show you a more sophisticated a more sophisticated example, and my colleague will do a live demo.
Thank you very much. So to show you a little bit what the demo is all about, I want to show you this example we prepared. It's running on Azure Databricks on a Microsoft cluster, but we also have a S3 storage just for the configuration files and for one of our layers in the data lake. All the data you see here is taken from Open Data Swiss, so you can also take a look at that if you want to. And as a starter, we already have one data source integrated into our data lake, and that's the location of all the 5G antennas in Switzerland. And so basically we have up to the integration layer where we basically have the location with X and Y coordinates between these. Can you switch to the presentation? Okay. Oh, sorry. So what we want to show you in the demo right now is how we would integrate a second source into our data lake. So I'm going to take another data source. I'm going to integrate it in our smart data lake. And we're going to combine these two data sets into one business view in the business transformation layer. So the red boxes you see here are basically our data objects, and the red lines are your actions that we have. So you can see different kinds of actions we have here. We have the file transfer action that just transfer the files, but we also have more sophisticated actions already out of the box, like the historize action. And the historize action is automatically historizing our data in the integration layer. And you can also see that for the business transformation layer, we have a custom transformation, because that's a little bit more complex. We need to join the data of these geographic locations of the antennas, and we want to know in which zip code and in which canton these antennas actually stand in. Yes, and with that, let's switch over to the demo. As I said, everything is running on Azure Databricks, so I'm doing most of the parts in a notebook here. And I've already run the first two cells. The first one is just to integrate this Amazon S3 storage, and the second one is basically to define this custom transformation that we need to join it geographically. I'm going to show you that afterwards. We can also take a look at the data that already exists. So I already have the antenna data here. You can see that it's automatically historized, so you basically have like a valid from and a valid to. So if a new version of the data is coming in, it's just automatically historized by the Smart Data Lake Builder. You can also see it's very nicely integrated into the Databricks service, because it's Hive tables. You can see everything here as well. So what I'm going to do now, I'm going to switch over to the S3 storage where I have my stage layer. So you can see the data we already have here. That's the 5G antenna location, just as a JSON file. And if I go back up again, you can see the configuration. And that's what I'm going to edit now, because I need to add these 4 data objects and the 3 actions that I've mentioned earlier. So because we don't have a lot of time, I'm just going to copy paste this, and then I'm going to explain what it actually does. So in this metadata, we have the data objects. We already have these for the antennas, and I'm going to insert it here for our zip code data. So what we have is one data object, which is basically the web service that we're going to call. We will store the files in a stage layer, which is just a JSON file. We will have the integration layer, which is a Hive table. And we're going to call this one int zip codes. And the 4th object that combines the data is called BTL location. That's our business transformation layer. So to make sense of this data, we need to insert the actions, of course. I'm also going to copy and paste that quickly. You can see the actions we already have for the antenna locations, and I'm going to insert that. So let me explain that quickly. We have these 3 actions between the data objects. So the first one is simply the file transfer from the web service into our stage layer, into the JSON files basically. The second one will just copy the files from the stage layer to the integration layer. But here I define the transformer SQL code in the form of a SQL code. So for quite a few tasks, you just need to write SQL code. You don't need to write any sophisticated Scala code for that. For example, here I'm just going to filter a few of the data sets. That's why I have a where clause here. And for the last part, for the business transformation layer, as I've mentioned, this is a custom action because I need to do this geographical join between the antennas and the zip codes to figure out where the zip codes stand in. So I'm going to use both integration layers as input, and I'm going to output the business transformation layer. But here I've not defined a SQL code, but really a Scala class name. So I'm going to show the class afterwards. So I've added all the data objects, all the actions. Let's save that and switch back to the Databricks cluster. Now I'm just going to execute that quickly because it will take some time, and then I can explain in the meantime. So we already have a job set up that will trigger our Smart Data Lake Builder. Everything I'm doing here is just providing a few parameters. So one of these is the parameter what actions I want to run. You can group your actions. You can only run certain parts. Here I've defined a regular expression to just run basically everything. So what the Smart Data Lake Builder is doing now, it's going to figure out all the dependencies between these data objects. So it knows, I hope it will figure out that it needs to load the stage layer before it can load the integration layer, and it needs both integration layers to basically load the business transformation layer. So I don't need to define any of these dependencies. It will figure this out from our metadata. And I'm pointing to the configuration. That is just the S3 storage at Amazon again that I'm pointing to at. So let's quickly take a look at this custom transformation. As I've said, we have this geographic join. All I'm doing here, I need to override this method transform. And in this method, you get your data frames in. You can do basically anything in here, and you give your data frame back at the end. Here, I use some libraries to do this geographic join, but you can, the options are basically limitless here. So let's take a look what the job is doing in the meantime. I can see here, that's the run from now. The job has finished. I can also check the logs quickly of the job, and you can see here the result that it drew the whole diagram of the dependency. So it loaded the stage layers, it loaded the integration layers, and it loaded the business transformation layer successfully. So now we should be able to go back into the notebook and take a look at the result. So now I should have my zip codes in an integration layer. I'm just going to show the schema here. You can see in the integration layer we still have very complicated schemas with structs and arrays and everything. But if we take a look at the business transformation layer now, you can already see that the data scientists can work much, much easier with this data. So I have my IDs of the antennas, but now I also have the zip code where the antenna is standing in, and I have the canton in which it stands in. And from there, of course, you can imagine it's very easy to go on and do your data analysis on this business transformation layer. As I can show here, just group everything, for example, by canton. And of course also with visualizations. And as you can see, in Zurich and Bern, we have the most 5G antennas, which I guess makes sense given the population density and the area. But you can, I hope you saw that it's very easy to integrate new data sources into your data lake and prepare them very, very efficiently for your data scientists to use the data. With that, I'm going to give back to Zacharias quickly.
Thank you very much. Worked like a charm. Can I see the slides again? So we couldn't show all the features Smart Data Lake Builder supports in this short demo. There are some interesting things like schema evolution for complex types or early validation. So if you reference a column at the end of your data pipeline, which doesn't exist, it fails early. We're also working on integrating Python, so you can define your transformations in Python or a dedicated action so you can run your machine learning models directly. The smart data lake is the core, or is the core of a modern analytics platform. To build and operate and maintain it efficiently, you need an automation tool. And we estimate savings of up to 50% on several aspects using an automation tool like Smart Data Lake Builder. So I thank you for your attention. I hope we were able to show you how a strong data foundation for AI and ML could look like. In the demo, we have seen how to easily and efficiently create this. And if you like to know more about it and Smart Data Lake Builder, don't hesitate to contact us at ELCA.
Thank you very much, Zacharias and Patrick. Really worked like a charm and was quite impressive, actually, because I suppose this is a problem so many companies are struggling with, actually getting different data sources with a variety of formats together and work with it, and you automate this. This is really impressive. So is the system up and running with SBB only or with the different companies already?
Yeah, we have several customers using it already. SBB has many jobs running on an older version of it, and we invested in it, making it supporting more and more use cases and making it open source. Yeah.
Okay, why the decision to make it open source?
I think first it's based on open source tool. Why don't also make the top layers on it open source and give something back? And on the other side, I think it's interesting if such frameworks are used by many companies, many organizations, and we can learn from each other and support more environments, more use cases like that.
It's also very easy to extend, of course, and we can't, for example, build connectors for all the systems out there. So we focus on the ones that we use ourselves, of course. But because it's so easy to extend, we expect a lot to come back from the community as well. Yeah.
That's a very nice closing word. Thank you very much for this interesting insight into the Data Lake Builder. Thank you very much.
Thanks to you.
Thank you.